All right, well, let's go ahead and dive in. We've got a full agenda for you today. Welcome to the Cable Stage 2 webinar. We're going to be talking all things Cable Stage 2 and lots of details, and we're really happy that you're here. Ryan, you can, yep, perfect. So just a few quick housekeeping items before we dive in. Please enter any questions that you have in the Q&A. I know lots of times you want to put questions in the chat, which just know we're keeping an eye on the chat, but if you could put your questions that you'd like us to answer at the end in the Q&A box, that will help keep us organized. We'll do our best to keep an eye on the chat as well, but I know sometimes it can get missed. If you have any technical issues, please check your audio settings under the audio tab. You might need to call in. And if for whatever reason you can't work through the technical issues, we will be posting a recording of this webinar following our presentation today. All right, like I said, we have a jam-packed agenda for you today. We're really excited to talk to you about Cable Prize Stage 2. We're going to kick off with an overview of the Usdoe Advanced Manufacturing Office and the American-Made Challenges and Network. Then we're going to talk about the broader cable initiative and the ecosystem. Then we're going to move into an overview of the Cable Conductor Manufacturing Prize. Some of you were with us for Stage 1. Some of you might be brand new to the prize. We're going to give a little bit of background, and then we're going to spend the majority of our time today talking about Stage 2 and the rules that were published on April 21st. We'll then finish off our presentation with a quick live demo of HeroX, and then take any questions that you might have. We'll do our best to get to all questions, but we will certainly post answers following this presentation as well. So my name is Emily Evans, and I'm a prize administrator for the Cable Prize. I work on the American-Made Challenges program, which is run out of the National Renewable Energy Lab. I am joined today by a great panel of speakers. To kick us off, I'd like to introduce Tina Karsberg, who first conceived of the idea of the Cable Initiative and the Cable Prize. She's a physicist and a fellow of the American Physical Society, Tina has spent the last 20 years working for the US government in various offices at DOE and on Capitol Hill. I would now like to invite Tina to the floor to introduce the rest of today's panels and to kick off our presentations. Tina, over to you.
Thank you. You can hear me?
Can hear you great.
All right. Thanks, Emily, and good afternoon, all you Cable Prize interested persons. I'm with DOE's Advanced Manufacturing Office, but as Emily noted, I'm also the lead of the DOE cable team, which includes members from the 7 technology offices within EERE, the Office of Electricity, ARPA-E, and the Office of Science. When I'm asked what cable is about, or what the Cable Prize is about, my shorter answer is it's about electricity. The longer answer is what you're going to hear about today. I'm joined here by 3 members of the DOE team, Dr. Chris Oshman, Mr. Cameron Bourdonnais, and Dr. Kemai Tren, who all provided invaluable contributions to the Cable Prize rules that are the topic of today's webinar, as well as other parts of our cable research ecosystem. Chris has been with Cable since the very beginning in 2021. He has a PhD and is a registered professional engineer and has had several different positions before his AMO fellowship, including work at a high temperature superconductor company. Cameron is the newest member of the AMO team and works as an on-site contractor with Energetics. He has a chemical engineering master's and previously, Kemai Tren, who also has been with Cable since 2021, is a second-year fellow at AMO, supporting technical partnerships. Prior to AMO, she worked on hydrothermal continuous flow nanoparticle synthesis and characterization at Argonne National Laboratory, and has a background in material science and engineering from the University of Florida and Rice University, where she worked broadly in green electrochemistry. And now I'd like to talk a little bit about AMO. This slide summarizes our office organization and mission statements and our most recent budget. Our office supports research, development, and demonstration, or RD&D, aimed at improving manufacturers' energy efficiency and the efficiency of the products they produce. In addition to energy efficiency, the office has a strong and accelerating focus on decarbonization through manufacturing and on solving manufacturing challenges for the clean energy industry. This work is built on a foundation of effort in material supply chains and high performance materials, and is accelerated into the market through technical assistance and workforce development. Next slide, please. So here are more details of the AMO program structure, and this over here in the yellow is where CABLE fits in under materials. After all, C in the acronym CABLE stands for Conductivity Enhanced Materials. In addition to increasing the efficiency of all electricity use, materials with enhanced conductivity can specifically help transition us to a zero carbon grid by 2035 by lowering costs and shrinking the footprint of electricity delivery systems, increasing grid resilience to extreme temperatures and weather, and lowering costs and improving performance of renewable generation and electrical equipment. And within this slide in particular, you can see the cross-fertilization in these categories. For example, CABLE enables industrial heat pumps, which are in the blue box at the left, and electrochemistry in the green box. Emily, back to you.
All right, thank you, Tina. Now we're going to keep moving forward and move into a short overview of the American-Made challenges and the American-Made network. Next slide. For those of you who might be unfamiliar with the American-Made program, it is powered by DOE and administered by NREL to incentivize innovation through prizes, training, teaming, and mentoring. The American-Made program serves as a fast track to participants to engage in the clean energy economy, connecting innovators and entrepreneurs with America's national labs and the private sector. Next slide. The AMC program was started 4 years ago with one prize. Today, the American-Made Challenges is 30 prizes strong, with more than 10 DOE offices, 250 plus industry and national lab partners, and $100 million in cash prizes and support. Thanks to rapid timelines and goals, prizes are able to fast track product development from years to months and enable rapid innovation cycles to create partnerships that connect entrepreneurs to the private sector and the U.S. Department of Energy's national laboratories. Like the CABLE Prize itself, the American-Made Network supercharges research on bold new ideas. We're excited that you all are here to learn about the CABLE Prize Stage 2, and I would like to invite you to check out AmericanMadeChallenges.org. We are launching new prizes all the time, and I would encourage you to take a look and check back often. The American-Made Network is 250 plus amazing organizations called connectors who help identify competitors for prizes and support them as they refine their innovations and submission packages. They also introduce competitors to mentors, industry partners, investors, and also help to provide resources, tools, facilities to catalyze their technology commercialization. The network is growing rapidly with connectors across the country, with about 50% growth over the last year. If you're interested in learning more about our network, or if you're interested in becoming a connector, please visit AmericanMadeChallenges.org/network. And we've been dropping these links in the chat for easy clicking, so please do check it out. Tina, back over to you. And Tina, you're on mute.
Yeah, making sure you don't hear my dogs when I'm not speaking. Okay, well, as Kimmy likes to say, CABLE has a dual meaning. First is that it literally stands for electricity cable, including the one behind me, and also transmission cable. That is actually the first applications we thought of when we conceived of our big idea about conductivity enhanced material. But it's also an acronym that stands for Conductivity Enhanced Materials for Affordable Breakthrough Leapfrog Electric and Thermal Application. Besides CABLE, I just want to point out that this 50 new logo for AMC looks like a field of flowering manufacturing ideas. All right. So, speaking of manufacturing ideas, the U.S. Department of Energy launched the CABLE initiative as part of a Big Idea contest in 2021. The prize is one of a trio of activities, including also CABLE SBIR and CABLE workshops that were launched that year. This three-stage competition, speaking of threes, the three-stage prize competition over 3 years will award up to $4.5 million to spur development of affordable manufactured materials that increase the energy efficiency of all electric devices. The CABLE Prize aims to help U.S. energy and manufacturing industries by rapidly identifying, verifying, and rewarding new materials and manufacturing methods that achieve significant enhancements in electric conductivity. Competitors must also offer a pathway to produce the new conductivity enhanced material affordably. Next slide, please. And we had really broad participation across DOE because of CABLE's broad applicability and its contributions to decarbonization, especially electrification across all sectors. CABLE supports the EERE technical priorities of industrial, grid, transport, building, and agricultural decarbonization through increased energy efficiency and lowering costs and improving performance of all electrified technologies. In parallel, CABLE helps AMO in particular cut greenhouse gas emissions in half by 2030 and net zero by 2050 by also contributing to decarbonization efforts related to process intensification, separations, and process heating and drying efficiency. Next slide. So here are our 2021 results and our latest 2022 results, where we've leveraged the American-Made Challenge Network and DOE Small Business Innovation Research and Small Business Technology Transfer programs to enable U.S. manufacturers to leapfrog international competition by upgrading the fundamental materials. What's going on here? Oh, yes. Starting from the left, on Nanotechnology Day last fall, we announced the 10 winners of Stage 1 of the CABLE Prize, grouped here into 4 categories, involving metal with or without nanocarbon, carbon nanotubes, graphene, or carbon that turns into graphene. A metal without nanocarbon finalist is a nano process to make aluminum as strong as steel, but 7 times more conductive. In the non-metal category, we got 3 non-metal entries involving metal. First, a carbon nanotube with added copper, the second, a carbon fiber intercalated with transition metal, and the third, a high temperature superconductor that also has some copper, but costs 50% less than copper to manufacture. Also in our non-metal category, we had some conductors without any metal at all. Both were based on carbon nanotubes. You can read a lot more about the SBIR programs on the SBIR website indicated here. And now Chris will tell us about the third leg of the CABLE stool, the workshops. Chris, over to you.
All right, thanks, Tina. The CABLE innovation ecosystem is currently comprised of the SBIR program for small business research, the prize program, and a workshop series. In 2021, the SBIR program, it focused on a variety of materials and applications, while this year's SBIR is focused on modeling and materials development. The CABLE Conductor Manufacturing Prize, it's now in Stage 2 after awarding that array of Stage 1 prizes. Last year's CABLE workshop indicated a need for more detailed theory, modeling, and simulation of conductor materials. And all of these components, they work together to advance the CABLE initiative and to develop a robust network of entrepreneurs, scientists, engineers, national labs, and government partners. Next slide, please. We're excited to announce the second annual CABLE workshop, which will be a hybrid event taking place July 20 and 21 at Argonne National Lab in Chicago. And here we're going to bring together specialists from all parts of the research ecosystem, including inventors, scientists, manufacturers, and market experts. Day 1 will include various activities, including a lab tour, deep discussion on testing and characterization, a technology showcase, and networking events. The second day will involve discussions on the various electrical conductor types, their theory and modeling, and we will wrap it up with conversations on commercialization. You can now sign up for the virtual part of the workshop and get on the mailing list to receive in-person registration info. And all of those contacts are listed on the bottom of this slide. And I think they're also in the chat. Next slide, please. And I think Emily, you're up.
Thanks, Chris. Really appreciate it. All right. In this next section, we're going to do a short overview of stage 1 of the CABLE Prize. Again, the CABLE Prize is that first leg of the cable ecosystem stool that you've heard us talk so much about, and the reason why we're all here today. And really, the best way to introduce the CABLE Prize is to start off with a short introductory video. It's about 2 minutes long. While it's going, I encourage you to think of questions about the prize and anything that we've presented to date. Obviously, you're going to get a lot more information. Remember that you don't have to wait until the Q&A period to start posting your questions into the Q&A box. We are monitoring that live and may answer questions as we go or answer it live during the Q&A. But let's watch the video and then we'll dive in.
From trains that crisscross the country to the chargers that power your electric car, conductors play an essential role in moving electricity and you from point A to point B. As our society becomes electrified, technological breakthroughs are helping to decarbonize our industrial processes and power everything from the heating in our office buildings to the power tools in our garage. We have the power to make every electrified process more affordable and efficient via the development of breakthrough enhanced conductivity materials. To supercharge the effort, the U.S. Department of Energy's Advanced Manufacturing Office is launching the Conductivity Enhanced Materials for Affordable Breakthrough Leapfrog Electric and Thermal Applications, or CABLE Prize. The $4.5 million three-stage prize will help boost leading U.S. industries and upgrade the materials and applications that support grid reliability, electric vehicles, heat pumps, and more. Stage 1 will bring together the diverse conductivity and manufacturing communities. Competitors will submit their best and brightest concepts for developing a new conductivity-enhanced material. Up to 10 winners will receive $25,000 in cash awards, as well as a stipend for third-party testing of their material in the next stages of the prize. Have we electrified your imagination yet? Put your ingenuity to work to accelerate American entrepreneurship and leapfrog your competition. Learn more on our website and take the CABLE Challenge today.
All right. Thank you for that. All right. I really hope you enjoyed that video. I always love those videos. I think they're a lot of fun. But let's go ahead and dive in. To help ground our discussion today, I want to take a moment to highlight the overall goal of this prize. And the CABLE Manufacturing Prize really seeks to push the frontiers of science and engineering and drive American innovation for materials that can lead to the development of clean energy technologies that are critical to the climate solutions. Really, you know, CABLE is just at its core so important for the big challenges that we all are facing and need to address. Before we dive into the details, here is a prize summary slide. The CABLE Manufacturing Prize is a 3-year, 3-stage prize worth at least $4.5 million in prizes and vouchers. This tiered prize is designed to supercharge the CABLE innovation ecosystem and accelerate commercialization of materials that will help to lower the costs and energy use of electrification. So looking at each stage in a little bit more detail, in stage 1, we saw concepts to develop and manufacture conductors. It was based on written proposals only. Now in stage 2, we're taking that concept development one step further to ask teams to create lab scale samples for conductivity testing. It's important to note stage 2 is open to all competitors, both if you participated in stage 1, if you won stage 1, if you didn't win stage 1, and brand new competitors. However, you must win stage 2 to participate in stage 3. If you want to join in on the CABLE Prize, this is your opportunity to do so. In stage 3, we're going to push competitors to create manufacturing scale samples and and do much more testing of those samples. A quick note that likely many of you have observed, in every stage we release an outline of the next stage because we want you to know what is coming and what to expect. However, we always wait to release the next stage's full rules so that we can incorporate the learnings and findings from the previous stage to improve the subsequent stage for everyone. For example, in stage 1, initially we didn't think that superconducting materials would be affordable, that would fit under the goals of this prize. However, that we learned that due to technological advances, certain superconductors might even be competitive with copper. And we're going to see that and measure that in stage 2. We're going to talk more about that later on, but just as an example of how we're thinking and designing this prize. So as I mentioned on the previous slide, stage 2 is now open for competitors to take their materials from concept to reality, producing a micro scale sample of their material for evaluation by the CABLE Conductor Manufacturing Prize approved testing laboratories. Stage 2 is open to all new and returning competitors. Again, you must win stage 2 to compete in stage 3. Winners of stage 2 will each receive $200,000 in no strings attached cash prizes and $100,000 in technical assistance vouchers for work with either DOE National Laboratories or the American Made Network. If you intend to compete, please be sure to read the stage 2 rules document. We're going to drop the URL in the chat. Although we're covering the most critical elements of the rules today, there's still lots of important information in the official rules document. We can't possibly cover everything in the time that we have today. So please, I highly encourage you to read the rules in full and ask us any questions that you might have. Finally, for stage 3, we are anticipating that this will look mainly at scale up and very specific application markets. We are currently anticipating to do even more rigorous testing in stage 3 and plan, just like we did between stages 1 and 2, to release the full stage 3 rules following the stage 2 winner announcement. In stage 3, up to 4 competitors will be splitting a $2 million prize pool. And just to note, we're going to talk about this a little bit more later on, but we are seeking to identify new stage 2 and stage 3 co-sponsors for this prize. Co-sponsors for stage 3 or stage 2 and stage 3 could come from private industry partners, environmental or philanthropic groups, other offices within DOE, and even other agencies like DoD, NIST, NASA, etc. We are seeking both financial sponsorship to increase our prize pools, as well as in-kind sponsorship for things like technical mentorship and support for our competitors. We're especially excited for co-sponsors once we start seeing these qualitative results of the prize. And just real quick, this is our future anticipated timeline for stage 3. But as always, these dates are subject to change. And now to get into the nitty-gritty of the technical requirements for stage 2, Cameron Bourdonnais of Energetics from the DOE team will walk you through. Cameron, over to you.
Thanks, Emily. So potential stage 2 prize competitors, this section is for you. Please put any questions you have during this section in the Q&A chat. So first, some specifics on the prizes. As noted by Emily, not just 10 stage 1 winners, but anyone can compete in stage 2, which will have up to 6 winners. These winners will be competing in a pool of up to $1,200,000 in cash prizes, or $200,000 per winner, and up to $600,000 in technical assistance vouchers, $100,000 per winner. They'll also be receiving stage 3 testing stipends. Speaking of vouchers and testing, next slide, please. In stage 2, for the first time, CABLE Prize competitors can take full advantage of the AMC network that Emily described by signing up for vouchers. Stage 2 winners will receive a $100,000 voucher for technical assistance that they may use to fund work at national laboratories and other facilities to accelerate the production, testing, improvement, and/or validation of their conductive materials for the Stage 3 competition. Prize administrators will provide competitors with opportunities to meet with potential voucher providers ahead of the Stage 2 submission deadline. Competitors must identify voucher providers and include a high-level overview of proposed work provided in the final Stage 2 submission. 2 upcoming events where competitors can meet voucher providers are the in-person at the July CABLE workshop and the final virtual meetup event to be held on August 18th. Please see the links in the chat for registration information for these events. Now back to the competition details and why we developed them. We issued an RFI, request for information, in November 2021. The proposed specific testing requirements and sought input on other aspects of the Stage 2 contest, such as the inclusion of superconductors and the room temperature equivalent conductivity calculation. Stage 2 documentation, including overall conductivity goals, materials and manufacturing cost documentation, and so on. This also included the Stage 2 schedule, testing, logistics, and potential vendors, and general feedback. Next slide, please. So here's the timeline for Stage 2, based on feedback from Stage 1 and the RFI we held. We are allowing competitors 6 months from the opening of Stage 2 until their samples are due to the testing lab. August is the deadline for testing registration, and December is the submission deadline. I want to remind you again of the upcoming CABLE workshop in July. Next slide, please. So here is the core of the competition. 3 conductivity contests. Conductivity is the C in CABLE, and in this stage, we're testing it. And the test results account for half of each competitor's score. Based on the Stage 1 results, we decided the best way to have different conductors compete was to compare them to the materials used in most conductor markets today. The biggest conductor market is copper, which accounts for 3/4 of the sales of general purpose conductors. Aluminum dominates the lightweight conductor market, which accounts for about 1/4 of the conductor market. We also have a contest for widespread conductor system applications, such as power lines, which would include both aluminum and steel for strength. The testing points will be assessed according to the amount by which the competitors beat thresholds shown here. The other half of the contest points will come from reviewers' assessments of the plans to scale up and commercialize their materials. Next slide, please. So this other half of scoring is based on competitor-supplied narrative, their data, PowerPoint, video, letters, and our reviewers' assessment of them. The first 3 of the 5 goals listed here are spelled out in the letters of CABLE: affordability, breakthrough, and life cycle. Based on the feedback of our RFI, we reinterpreted affordability because it's implausible, if not impossible, to take a base conductor, such as copper and aluminum, do something to it, like add nanocarbons or process it in a new way, and have the resulting material be cheaper than the base material. Hence, affordability metrics now focus on long-term, greater than 10-year life cycle, and how that would lead to eventual economic competitiveness of the material compared with existing conductors in major markets. Most of the points for the level of breakthrough come from the testing, though we do ask that the competitor's explanation of why their material has enhanced conductivity or other properties makes sense. L is for life cycle. We also added 2 new goals: manufacturability, measured mainly by testing, and commercialization, which is measured by narrative and data requests inspired by those required by SBIR proposals. And now to get into more details, back to our CABLE team lead, Tina Karsberg.
You're muted again, Tina.
Thanks, Cameron. As he mentioned, the key parts are the testing and the reviewer's assessment of the submission materials. We are also asking you to classify your entry as either a metals or non-metals or a superconductor to help us get the right expertise for our reviewers and judges. The first category of experts, we really need metal experts, both experimentalists and metallurgists and theorists who know metals. In the second category, we, of course, experimentalists and theorists who know carbon, carbon fiber, nanocarbons, such as CNTs, and we, as well as polymer scientists and experts in all kinds of nanoparticles. In the third category are superconductor experts, and we are reaching out into a new community that we haven't worked with before, and hope to get some help on that from all parts of DOE. Next slide, please. Well, speaking of superconductors, our stage 1 judges convinced us that the high temperature superconductor manufacturing and cooling costs had dropped so much that they should be explicitly included in the contest. The problem was we needed, we want to have a contest based on the best conductivity that we measure. But superconductors, by definition, have infinite superconductivity or zero resistance below their critical temperature. So as Cameron mentioned, we proposed a solution where we calculate an effective conductivity number, or as the acronym is RTEC, or room temperature equivalent superconductivity, that includes two factors: a linear cooling penalty, the delta T, and a manufacturing cost reduction credit. Only superconductors that are lower cost than copper to manufacture and don't require expensive cooling equipment would qualify for the contest using this equation. Next slide, please. Okay, now for a little more on the conductivity competition. As Cameron, this slide is so important that we're repeating it, except this time with more details. The most important part of contest 1, of course, is the conductivity in megasiemens per meter, which should exceed that of the best commercial copper, or 102% IACS. A couple of other caveats. Since silver is 8% more conductive than copper, you could, in principle, meet this particular testing threshold by just adding silver. We doubt it would be that affordable, but just to be clear, materials competing in this contest number 1 must not include any bulk silver. In addition, for the other important attributes of copper, for example, corrosion resistance, your material should be as good as or even better than copper. The second contest, also known as the lightweight conductor contest, the most important aspect is that your material exceed the conductivity of pure aluminum, plus have a density equal to or less than that of aluminum. Similar to contest 1, it cannot include any gold, which has conductivity higher than aluminum. Of course, it wouldn't take too much gold to make your material too heavy and or too expensive. But just to be clear, your material must not contain bulk gold. Plus, other properties must be as good as or better than those of aluminum. The final contest, and the one with the lowest megasiemens per meter conductivity requirements, is the conductor system contest. To compete in this contest, your material must be able to substitute or exceed the properties of a common conductor system, such as the aluminum conductor steel reinforced cable shown in the picture. It can be other conductor systems, provided the system involved is one of the conductors in the Rules Appendix A, and provided that the application is widespread, very widespread, and that your material has same or better conductivity in the current system and the same or better other properties such as strength. Next slide, please. So speaking of ACSR, it is an excellent example of a widespread conductor system because it is the #1 conductor system for millions of miles of overhead power lines, with estimated sales exceeding 30 billion worldwide in 2022. In addition, this huge market is likely to keep growing as the US needs to triple its transmission lines to meet its zero carbon grid goals by 2035. The systems like ACSR have lower net conductivity because they include steel, which is not considered a conductor for the purposes of the prize because its conductivity is only 8% IACS. The system conductivity is 44% IACS. So the conductivity to be for this conductor system is lower than that for the beat aluminum contest. Other widespread conductor systems might involve nickel, which until recently at last cost less, had lower conductivity, but had very high temperature and corrosion resistance. We don't have a list of all the potential conductor systems at this point because we want you to think out of the box and be creative and also do your homework on conductor markets. So we don't have a really hard and fast definition of what conductor systems are, but this is a good example. Next slide, please. As mentioned earlier, tested conductivity values account for half of the points in this contest. This table, which you will see a lot of today, is how the testing points are allocated to the two most relevant prize goals, which are breakthroughness and manufacturability. Now, the relative contributions of breakthroughness and manufacturability will probably vary conductor to conductor. So we decided the best option for everyone was to just divide the points 50-50. Conductivities for each qualifying contestant in a contest will be ranked and the points allocated by rank. The material that has the highest conductivity gets the highest or the maximum number of points. Now onto the details of the first column, the criteria point. Next slide, please. Okay. For each criteria question, the reviewer can award your entry up to 6 points according to the rubric shown here. Based on the 17 criteria that are described in the section on technical narrative, plus the 3 criteria in the diversity section, you can score a maximum of 6 points per criterion, or 120 total points. The criteria scoring is based on the corresponding write-up in the technical narrative or diversity section, and as supported by your video, your summary slide, your letters of support, your diversity plan, and your Appendix C template. So there's, while you're strongly encouraged to address the technical narrative, those other things are really important, as I will detail in a moment. Next slide, please. Okay, in case that list went by too quickly, here it is in a slide. The 120 criteria points are based on the totality of your package, including the new template in Appendix C and the 4 questions in the diversity plan. Note that there is a word and graphics limit on the technical narrative and a time limit on the video. So any content that exceeds these limits will not be reviewed. Next slide, please. Okay, for the first element, there are 9 things that need to fit on your cover page. Most of these are pretty self-explanatory, but number 6, the summary, and number 9, the abstract, seem somewhat similar. So just remember the summary is shorter. It can even be a slogan or just spling out of your acronym like CABLE for us, or just a 1-sentence overview. We do X to Y materials to achieve Z results, but please try to have some technical content in your summary. Like world's best conductor is not enough detail. World's best extruded copper graphene conductor would probably be okay. Next slide, please. Okay, So one thing I noticed as a judge last year was that some people kind of went overboard on low production values. We do say that the video does not need really high production values. You shouldn't like spend a lot of money on it. It doesn't need to be super slick, but it should be well thought out and definitely not deliberately lame to show how non-slick you are. I've actually seen some competitors make that mistake and it hurt them. And also remember, this will be posted online for everyone to see. Next slide, please. Okay, the summary slide. One thing that I've noticed is that people feel that when they write their summary, it has to have different words than their slogan or acronym or abstract. And actually, it's really good to repeat because we're really busy people and we're looking at lots and lots of different entries, and repetition is very important for us to remember. So please, whatever, your slogan, your summary, or your title, your team, use the same exact words if possible. Don't feel you have to vary it. We won't get bored. Exact repetition of important things is very good. That's why we show you the headlines and the URLs over and over and the points table 3 times. Next slide, please. Okay, technical narrative. Unlike stage 1, where the technical narrative accounted for nearly all of the points, here it is somewhat less than half, but it's still super important, especially as you can see here on the right for affordability and commercialization. And of course, it's a good test of whether you can follow directions and have read the rules, as Emily said. For example, on the left, for all 20 criteria, we have something called suggested content. Now, you don't have to follow it exactly, it's just a suggestion. But generally, if our suggestion is to provide specifics, please do your best to provide specifics, even if it gets repetitive. For example, if it says the cost plus savings for your material, the net cost, should not exceed the current cost, you must explain why it doesn't, or to get a full score for that criteria. Next slide, please. A new key aspect of stage 2, the judges will use the quantitative data from Appendix C as a way to calibrate your forecast for commercialization. In Section 1, you have to make a market forecast. In Section 2, you provide some of the underlying future materials and energy data for these forecasts. And then in Section 3, you need to provide sample preparation data. And the reviewers will assess the probability of going from your sample costs and materials to your eventual commercialization costs and materials given your technical narrative. So that's why we ask for details on both. Next slide, please. Finally, there is Appendix A, which is very similar to Appendix A of the Stage 1 rules, which has our sort of universe of conductors from which we expect you to select for the contest that you will enter. For example, we list the density of all the conductors that are less dense than aluminum. We bolded them. So we therefore expect that anyone entering the contest for lightweight conductors might include some of these bolded elements in their material. In general, Appendix A has the bulk electrical conductivity of common conductors, which are mostly metals in pure form unless otherwise noted. These values have been accepted for decades, or in the case of copper, for more than a century. The metals, silver, copper, gold, and aluminum, are thought to be the most conductive because each of these elements has a full D shell of electrons with an outer S shell. The reason that silver is the most conductive metal and the reason for the order silver, copper, gold, aluminum is still unknown. So if you guys have any thoughts on that, we want to hear them. And also, we use both megasiemens per meter and the International Annealed Copper Standard, or IACS, which was set in 1913 as 100% IACS equals 58.1 megasiemens per meter at room temperature of 20 degrees. By comparison, the conductivity of aluminum alloy conductor used widely in electrical applications, or aluminum 1350, is about 62%. Conductivity of commercial copper wires for electric applications is often 101 IACS. And the highest conductivity commercially available material, silver, achieves 108% IACS, but costs far more per gram and has 1/3 its strength. So this is really the core of our competition. These conductivity numbers have really not improved appreciably over the past century. So even a very small percentage improvement in these conductivities would be notable and could have some very important practical applications. So, and one other thing, when we say microscale in this context, we mean the minimum sample size, which is something Kimmy is going to talk about. Next slide, please. Okay, another new element for stage 2 is the voucher work slide, where competitors list whom they have selected to perform voucher work for them, should they be a stage 2 finalist. This slide also accounts for up to 6 points under manufacturability. All stage 2 finalists automatically get K in voucher support from the AMC network. And as mentioned by Cameron, and I want to repeat, we have 2 upcoming opportunities for you to get some one-on-one time with potential voucher providers. You could meet them in person at the July 20th and 21st Cable Workshop, or August 18th, we'll have a final virtual meetup event to meet individually with voucher providers. And even if you really want to go it alone in terms of assistance or making your material, you should definitely take advantage of characterization services offered by many voucher providers, because that will validate your materials and increase the confidence of potential investors. Next slide, please. So, although we required a diversity, equity, and inclusion plan in stage 1, we didn't assign it a specific amount of points. In stage 2, we have 10% of your total points come from your diversity, equality, equity, and inclusion plan, and the extent to which you answer the 4 questions on benefits to underrepresented groups, your partnerships, your milestones, and actual or projected DEI employment impacts. Next slide. Letters of commitment can be very helpful, but if your letters are really pro forma and don't project a lot of enthusiasm and don't have many specifics, they actually hurt more than help. That's one reason they're optional. Also, while you can suggest bullets to your letter writers, please don't write the letter for them. As a judge, I had one competitor who had great, detailed, enthusiastic letters from several partners, except each letter was exactly the same. And well, that didn't help them. Next slide. Okay. This slide on maximum points is so important. I'm repeating it again, except this time I'm emphasizing the total points for your submission. And now for some details on the testing part of your submission, we have Dr. Tran, over to you.
Thanks, Tina. Well, actually, I think maybe next slide, please. Oh, there we go. Yep. Well, testing is obviously a huge part of stage 2, and there are 2 approved laboratories that you can use. You're definitely required to submit these samples of your materials to one of these approved laboratories. So CABLE Prize is offering a testing stipend to all competitors, whether or not you won stage 1 or not. So the stipend will cover not only 1 sample, but up to 3 samples of your conductivity enhanced material. And so if you have a non-superconductor material, which is a metal or non-metal, you can test it at NTS, which stands for National Technical Systems. And if you have a superconductor submission, that would be tested at Argonne National Laboratory. Next slide, please. And so I saw a lot of discussion in the Q&A, and that's great. Thanks for sticking with us so far. Hang in there. We're almost through. The samples to answer one of these questions kind of live here. For non-superconducting metal and non-metal submissions, they must be at least a minimum of 1.5 inches in length, although greater lengths are, of course, more ideal, and at least for a circular cross-section of 0.21 inches in diameter, or if it's a rectangular cross-section, at least 0.18 by 0.18 inches. Ideally, your sample will have a uniform cross-section across the entire length of your sample, where the cross-sectional area should not vary more than plus or minus 2%. And then finally, your sample needs to have a minimum electrical resistance of 20 microohms. Now, for folks with superconducting submissions, the requirements are a little simpler here. You just need a round or square sample, and one face of the film is is 5 square millimeters or less in area. So you are allowed to submit, oops, you go back just 1 second there. You can start submitting your samples starting September 1st, 2022 of this year. It's just around the corner. So obviously we really encourage you to submit those as early as you can, as if you have a submission postmarked after the deadline of October 17th, we will not be accepting those for the contest. All right, next, please. Okay, and then what happens once your tests, you've submitted your samples to the testing laboratory? The results are going to be evaluated and scored. So if you read through Appendix D of the rules, there is information on the sample testing data and this calculation scorecard. And so there's these 3 different values here that I'll go over. So first, for the testing vendor, they'll provide data on both, if you have a non-superconductor, that's the column on the left here, and on the right column is information for a superconductor. So for a non-superconductor, this vendor will give testing data that will be the average value of conductivity plus or minus the delta for the highest and lowest value. For a superconductor, the vendor will be giving you a value of the average value of critical temperature plus or minus the delta for the highest and lowest value. And they'll be giving the average value of critical current plus or minus the delta for the highest and lowest value at critical temperature. And the prize administrators will then take, will then calculate values. So for goal 1, for a non-superconductor, there are no calculated values, but for goals 2 and 3, the prize administrator will calculate sample density as a cross-check of the density that you submit using the density baseline from Appendix A, which is equation 8.1. Now for the superconductor submissions, the F is, they'll be providing the F ratio of the 10-year post-commercialization manufacturing cost of the superconductor. And that's in dollars per kiloamp meter, compared to copper, which is $50 per kiloamp meter. The room temperature equivalent conductivity, or as we fondly call RTEC, that calculation will also be calculated in millisiemens per meter. And that's based on that equation that we discussed earlier, and it can be found in Appendix C, equation C.2. Okay, and then lastly, the prize administrator will have ranked values. So judges will have access to these cards from all competitors, and the materials will be ranked based on the conductivity or the RTEC equation. And so either separate rankings by secondary goals or development of equations for the equivalent conductivity will be, for the secondary goals will be dependent on the entries that we receive. And so we anticipate that this Appendix D scorecard will be sent out to competitors about a month after the sample submission deadline. So roughly mid-November of this year is when we anticipate that competitors will get these testing results. Next, please. Okay, because again, this is such an important chart, and third time's the charm. We're trying to hammer it into you that these are the ways we're really scoring the points here. And as you can see in the orange column for testing points, testing is only evaluated for breakthrough and manufacturability here. And the number of points for qualifying entries will be determined by rank, with the top conductivity for contests 1 and 2 and the top market for contest 3 receiving maximally 120 points for testing. So to qualify for a prize, the stage 2 submission has to meet or exceed the requirements for one of those 3 contests, which was, as Tina mentioned, the beat copper contest, beat aluminum, or beat a conductor system. And I think that's it for me. I might turn it back over to Emily.
Thank you so much, Kamai. Can you hear me okay? I had to switch my audio.
Yep, we hear you.
Great. All right. Thank you so much. We are so excited about stage 2, and we hope that you're ready to dive in. I know you all probably have lots of questions about how do I get started in stage 2? What is my first step? And so I'm here to walk you through. So your first step is to create an account on HeroX and follow the prize. I'm going to be walking you through how to do this in just a moment, so stay tuned, and we'll be dropping that link into the chat as well. Your next step is to, if you haven't heard us say it yet, you're hearing me say it now, is read the rules. It is so important, and it's absolutely critical in CABLE Prize Stage 2 that you read the rules. And then finally, I would highly encourage you to sign up and attend the CABLE workshop that is happening both virtually and in person at Argonne National Lab this summer, July 20th through 21st. It's going to be a great opportunity for you to become very deeply engaged with the CABLE ecosystem and jumpstart your voucher scoping. Then in stage 2, or not stage 2, but step 2 in competing in stage 2 is to submit your stage 2 registration form. This is going to happen on HeroX, and it is critical for us to have you submit this registration form so that we know how many competitors we have and how many tests that we can expect. Teams must submit a stage 2 registration form no later than August 25th at 5 p.m. Eastern. You are certainly allowed to still compete in the prize following August 25th. However, you will be responsible for your own testing costs. Third step is to then submit 3 of your samples for conductivity testing. Both of our laboratories, NTS and Argonne National Lab, will be open for receiving your samples starting on September 1st. They'll do a quick check of them, make sure that they look okay. And you can submit your samples anywhere between September 1st and October 17th. Samples must be postmarked by October 17th in order for you to be eligible for stage 2 of the CABLE Prize. Highly recommend you getting your samples in sooner rather than later. Don't even put yourself up for the stress of making sure that it gets there on time, that you get to the post office. Just do it early. Then step 4 will be to submit your final stage 2 HeroX submission package. That's going to be all of the materials that Tina just walked us through. Your technical narrative, Appendix C, your diversity plan, all of that is going to be due in HeroX no later than December 1st at 5 p.m. Eastern. And then finally, this fifth step is that we will announce our stage 2 winners February 2023. We'll provide some more detailed dates on that as we get closer. But that's in a nutshell how you can get started in stage 2. Next slide. Obviously, that does not encompass everything that needs to happen. Again, read the rules. You'll see in here things like on August 18th, we'll be hosting that virtual voucher service provider networking event. We really want everyone to engage with that, but we'll be sending you reminders and updates as we move through stage 2 of this prize. Next step, and I believe this is the live HeroX demo, so bear with us for just one moment. I'm going to share my screen, and then I'm going to walk you through HeroX and what it looks like. Give me just one moment to get switched over here. There we go. All right, can you give me a thumbs up if you can see my screen okay? Great. All right, so when you go to herox.com/cable, this is the website that it's going to bring you to. This is what we call our HeroX page. It's basically the hub of all things Cable Prize. It is your first and best source of all information about the prize. This is where we post updates. This is where we update the timeline. If you are participating in stage 2 in any capacity, please, please, please get over to HeroX, click on the follow button, which you can find up here in the top right corner. That's going to then enable you to receive all of the updates about the prize as we move along. Other things, you can see an overview of the prize, get up to date on the timeline. Note that most of these dates are anticipated. They do tend to shift around slightly. Any updates, you can check out updates. We'll be sending out reminders, opportunities, things we want you to pay attention to. Really, really important that you pay attention to all updates. There is a Cable Prize form. You are more than welcome to post here. You can post whatever you'd like. You can ask questions. You can talk to other prize participants. You can check out who is in the Cable Prize community, as well as check out our stage 1 winners. Just click on these links down below the team names and you can see their videos from stage 1. Entries, same thing. You can see all of the entries from stage 1, get up to date on what the community is working with. Also resources, we have posted tons of resources here on HeroX. You have the official rules document that I'm sure you all will be going to go read shortly after this webinar. We also have all the stage 2 resources. So this is where you're going to find all of the templates for Appendix C and the DEI plan and the voucher work slide. Very, very important. And we'll also be posting FAQs as we go along and receive more and more questions. So very, very important. Sign up today. To submit your registration form, the last thing I'm going to show you is you will go to this button here that says solve this challenge. Click on that. It's going to ask you to agree to the competitor agreement. You can choose to create a team that just allows you to invite other members of your team to log in and contribute on HeroX, or you can compete individually. So then I've selected to compete individually. And so then it's going to replace that big button with these 2 buttons. Click on begin entry. And this is your stage 2 registration form. So you can see here that it is it's not super short, but it's not very long either. Should take you about 5 minutes to complete, go through, answer the questions. And this is going to set you up for success when it comes to shipping materials. Later on, once we get past the submission form, you're going to do that same process of clicking begin entry, but it will take you to the final stage 2 submission form, which will look different and give you places to upload your technical narrative. You can save and preview. If you want to work halfway through it and then finish it later, you're more than welcome to do so. Or you can, this will turn it into a submit button once you fill out all this information. So again, HeroX, very, very important. If you're not already a part of the community, go to herox.com/cable and click on that follow button and submit your registration form. Honestly, I'd just do it today. It's pretty quick, easy. You are more than welcome to edit it up until August 25th, but just get it out of the way. Check it off your to-do list. All right, And Ryan, if you want to go back to the PowerPoint presentation. All right. So to recap, to get started with stage 2 of the Cable Prize Challenge, create an account and follow on HeroX. Mark your calendars, get signed up for that Cable workshop July 20th through 21st. We'll be sending out an update with all of that information soon to the HeroX community. Read the rules, check out the FAQ, and submit your team registration by August 25th. And then finally, if you're in the audience today and you're like, wow, maybe I'm not a competitor, but I really want to participate as a partner of the Cable Conductor Manufacturing Prize. We are absolutely looking for co-sponsors for both stage 2 and stage 3. There are many, many different ways to partner with us. We're very interested, very open, very flexible to ways that serves your organizational goals and mission. Some examples of ways that you can partner with us: you can provide competitors with mentorship or technical assistance, provide additional in-kind or financial awards to winners, or you can simply just help us to amplify the Cable Conductor Manufacturing Prize and promote our competitors or provide opportunities to competitors. Lots and lots of different ways. We would be so excited to work with you. If you're interested, please reach out to us at cableprize@nrel.gov and we'll get back to you right away. All right, now we're going to transition to the Q&A section. Thank you everyone who's been submitting questions. We'll try to get to as many as possible. If you have additional questions, please drop them in the Q&A. At this time, I would ask all panelists to turn on your videos, unmute yourself. Ryan, it looks like we're being spotlighted. It might be helpful to have a different view here, but we will go through, and panelists, please jump in on whatever question that you would like to answer. Let's go ahead and kick off. I think we answered this one, but just maybe to say it again, what is the definition of a microscale conductor material? Oh, it looks like Tina has had to jump to another call. But I wonder, Kamai, I think we covered that. That was that's the sample size. I wonder, Ryan, could you go back to slide, see here, that was slide number 50, if you would.
Yeah, I think Tina might have answered that one live. It
was, okay. Well, anyways, it's in the official rules document. It's under the sample testing guidelines. There are specific sizes for both superconductors and non-superconductors. Again, read the rules, it's all in there. Another question that we received about testing was, will testing organizations publish the results that may be referred to in future journals and works? And the answer there is no. All of that information will be privately held by the administration team and then shared with individual competitors. We don't have any intention of publishing those testing results, at least within the stage 2 contest. And certainly that will be a discussion with competitors. Let's see here. Another question is about kind of who can contribute to the Cable Prize, who can add names of metal experts, how can they get involved? And the answer is absolutely anyone who knows someone who might be interested. Please help us get the word out. We are definitely looking for ways to increase our reach and amplify the Cable Prize. We want to reach as many people as possible.
Emily, would you like those folks to email that email address you provided?
Yes. Okay. And to get started, that's a really good point. Send any names or anything, any questions to cableprize@nrel.gov. Let's see here. Another question, and maybe Chris or Cameron, you could help out with this one. The stage 2 rules say that using silver is prohibited in the copper conductor submission. Is that correct? And if so, why?
Go ahead, Cameron. I think you know more about this topic.
Yeah, so that is correct. And it's not to say that silver isn't higher conductivity, but it really goes against the affordability. Silver is much more expensive than copper, and alloying silver with copper tends to actually have a lower conductivity than even just base copper. So utilizing silver as a starting point really goes against kind of the goal of the prize, which is to have an affordable conductor to replace those large markets that we already exist.
Thank you, Cameron. I really appreciate that. Maybe stick around. I have a question about Appendix A. This didn't necessarily come in as a question, but I think it might be good to clarify. So the numbers for the IACS in Appendix A, can you clarify kind of where those numbers came from, how we're thinking about them, using them as a baseline? Maybe provide a little bit additional detail there.
So once again, it's really just kind of a reference point. Those numbers have come from a variety of different public sources and documentation. And if you end up looking up those numbers, you might find that they vary a decimal place or so amongst the different sources, because some sources go off historical standards and some sources test individually, and tests have variance in results. It's really supposed to be a kind of reference point to guide the types of materials we want improved upon, and what materials might be included as you're creating new conductor systems.
Wonderful, thank you. Keeping on that conductivity thread, steel and then aluminum both have conductivity. In ACSR conductors, do you consider the conductivity of aluminum or both steel and aluminum in finding conductor resistivity? And then what about international standards, if you're able to answer that?
Can't speak much about the international standards, but for the ACSR conductors, the overall conductivity of the system, so you can either break it into the two parts, aluminum and steel, or you can look at the cumulative total. And again, this varies because there's no standard method for calculating the conductivity. There are ASTM standards that address it, but it includes both a function of the aluminum conductor as well as the steel reinforcement conductive material. So both of those values have an impact. So improving one or both, or changing the material for something that can provide the same functionality is all fair game in this competition.
Thank you, Cameron. We had a question about testing as well, and if competitors can send their samples to any NTS facility that had the ability to measure copper conductivity. And the answer there is that we're going to ask all competitors to send their materials to the same NTS facility, and we will be sending out that information to those registered competitors and the broader prize team, or the broader prize community as well. So we will ask that you send it to a single NTS facility, and we will let you know where to send that. We received another question about how competitors can protect their intellectual property. And this is a question that we receive a lot on prizes in general. And the answer is that intellectual property is up to the competitors themselves to protect. So whatever you need to do to protect your IP, that is the responsibility of the competitor. You are more than welcome. All of our, NREL, DOE, all of our prize judges and expert reviewers, they all sign an NDA. But however, if you wanted to put in like an NDA with the testing facility, you are more than welcome to do that, but you are responsible as the competitor. All right, let's see here. And I'm skipping around a little bit. If you don't receive an answer to your question live, we will be sending out a full response document, and we may reach out to you on a one-to-one basis here. We did receive a question regarding vouchers and kind of what does the term voucher provider mean. So as part of your stage 2 award, you are going to be receiving a $100,000 voucher for technical assistance that can be honored at national laboratories and members of the American-made network. So it's not necessarily the cable ecosystem, but rather the national labs and the American-made network. We will be hosting events throughout stage 2, first at the Cable Workshop and then virtually. In August, that's August 18th, we have that sign up link in the chat. You just might have to go and look for it. And at those virtual events, you will have the opportunity to engage with researchers at national laboratories. We know that sometimes it can be difficult to identify the proper resources and then engage with them. And so we're helping to facilitate that for you. All right, let's see here. If you have any other questions, please feel free to put them in the Q&A here. Let's see here. I think we've gotten to most of them. There are some really, really good questions. Again, definitely are asking for help with outreach. We have materials, we have newsletter blurbs, anything that might be helpful, we're happy to provide to you to help us get the word out. Reach out to us at CABLE Prize, all one word, at nrel.gov. And thank you so much for your support. Both this PowerPoint slide deck and the webinar recording will be available on HeroX following today's presentation. Give us a day or two. We'll send out a HeroX update when it's available. Please look through it. Please read the rules. I think we're just about at time here. So I'm going to go ahead and close out our webinar today, but I just wanted to say thank you so much to the entire CABLE community for coming out, supporting the prize, participating in the prize. We couldn't do it without you. Thank you so much to our panel today, Chris, Kim, Cameron, Kimai, Tina, thank you so much for your support, as well as to the broader NREL team. Thank you, Brittany, Danny, and Ryan. And that concludes our webinar. Thank you all for joining us.